Hello, my name is Julian Leonard. My Panther ID is 6060871, and I'm going to be doing the video solution for the final exam. Okay, so to start off, I'm just going to go by saying the answers. So for part A in this question, I got the answer of 0.225 amps going in the clockwise direction out of the page, right? For part B, I got a current of 0 amps. So obviously there's no direction. And then for part C, again, I got 0.225 amps, but this time going counterclockwise. And then as you can see in part D, I made my little graph, which shows a positive and negative current representation depending on the direction it's going. So if it's counterclockwise and clockwise, showing the positive. Okay, so to solve for, to show the solution for these parts, just really quick. So for part A and also for part C, we're going to be using two different equations. So the first one is how we calculate our current, which is just I is equal to E over R, electric field over resistance. Right. Then we are going to use the equation electric field, E, is equal to B V L, which is magnetic field, velocity, and length or area. So we already have basically all of these values, and when we combine the equations, we can get the total equation that is used of BVL over R, and we are given all of these values. So we're solving for I, and we are given a magnetic field of 1.25, a velocity of 3 meters per second, and a length of 75 centimeters, but we convert it to meters, so it would be 0.75 meters, all over a resistance of 12.5 ohms. And just by doing a simple division, we will get that I is equal to our answer of 0.225 amps. And then to show the direction, as a circuit is going into the magnetic field, the magnetic flux is increasing out of the page. And because it's increasing out of the page, that means it's going clockwise direction. Okay, so part B is a little bit different, because part B, we said the current was equal to 0, and this is because as the circuit is as the circuit is in the magnetic field, still in the magnetic field, it's still moving, right? So that means that because it's still moving, the actual magnetic flux is still 0. So we get an answer of 0, and obviously that has no direction. C, I solved the same way, so I'm not going to show the equation again. But the only difference now is that rather than now going into the page, we will be going out of the page, right? Which means it's going in the opposite direction, counterclockwise. And then lastly, for part D, we are simply showing the relationship between part A and part C, with part B as your intermediate, right? So when it's going into the page, we're showing positive direction. When we're going, when we are completely in the magnetic field, we are showing 0, right? And then when we are going out of the page or counterclockwise, we are showing negative. And yeah, that's basically it. Thank you very much.